Ionic bonding. Basically, this is how it works. Let's say you have two atoms. This one is hydrogen, and this one is chlorine. Hydrogen has 1 valence electron, and chlorine has 7. So it works like this. Hydrogen, since it has 1 to 3 valence electrons, is going to donate its 1 electron to chlorine, so it can have a full shell of 8 valence electrons. So hydrogen now has 0, and chlorine now has another 1. And this is a full shell. The atom that loses an electron becomes positive, and the atom that gains becomes negative. So now hydrogen is a positive ion, and chlorine is a negative ion. Now that hydrogen is positive and chlorine is negative, they are opposites and they're attracted to each other. So when they're attracted to each other, they're going to form a bond. Now you must find the charge of each ion. To find the charge of an ion for an element, you do how many they lost over how many they gained, and the bonding number. For example, hydrogen's bonding number would be positive 1 because it gives 1 valence electron to chlorine, which means that it's subtracting 1, but then it's actually adding because it's opposite. So yeah, chlorine would be negative 1 because since it's gaining 1 valence electron, it's actually subtracting 1.
Okay, so
So that was ionic bonding. Now let's talk about
covalent bonding.
So covalent bonding is much more simple than ionic bonding is. So basically, two atoms approach each other. So these two atoms approach each other. You got fluorine and chlorine. They each have 7 valence electrons. Because they both have 7 valence electrons, instead of one of them losing, they both gain by sharing 1 electron. So now, when they share these two, they are both donating 1 to the other. So now they both have a full shell of 8. So now they're stable. So basically, both of the atoms now have a full outer shell of 8.
Of 8 electrons?
Yes.
Of electrons.
Yeah. And let's show that. Well, we're going to show that in the last thing. So yeah, the end. Whee!